In this lesson, we're going to explore how to solve systems of inequalities. By the end of this lesson, you should be able to graph the solution and identify the solution set for a systems of two linear inequalities. We use linear inequalities in everyday life when we're looking at qualifications, such as National Honor Society, which requires you to complete at least 10 hours of community service and maintain a 3.0 grade average in order to be in the organization. And so we look for a specialized group of students, and they have to meet both qualifications. So they have to have more than 10 hours. Okay, so everything in this side, and they have to have above a 3.0, and both of those things have to be true. And so a systems of inequalities would help us to narrow down that field of students. When we look at a system of inequalities, this is like systems of equations, but instead of two or more equations, we have two or more inequalities. The solutions are going to be ordered pairs, and it's going to be multiple ordered pairs, not just one point, that satisfies both inequalities. And your solution is going to be a region, not just a point. So your solution is going to be a region that contains many, many, many points, and not just one specific intersection point. To solve a systems of linear inequalities, you're going to make sure that you change both of your inequalities into slope-intercept form. You're going to graph both of the inequalities. Remember our special requirements when we're graphing. The solid line or dashed line, and then when to shade above and below, and how to determine when to shade above and below with that test point. When we're shading to find a solution, you're going to shade the area that makes the statement true. So remember, you're going to use a test point such as 0, 0 in order to figure out which side to shade. If the test point is the solution, then shade on that side. If it's not a solution, then shade on the other side. And then the solution to your systems is going to be where the shading overlaps. Okay, so let's look at the following. We're graphing the systems of linear inequalities that are shown below. So we're going to start with y is less than negative x plus 1. So this says start your graph at 1. It has a slope of negative 1, so that says go down 1 and to the right 1. So make sure that your line is sloping downwards. Now because it's less than and not less than or equal to, this means that I have to have a dashed line. So I'm going to dash my line here. And then I'm going to use a test point. The test point is 0, 0 to figure out which side to shade on. So I plug in 0 for y, I plug in 0 for x, and I have 0 is less than 1, and 0 is less than 1, so I know that 0 is a solution here. So this says to shade everything that is below, everything that is on the side that 0 is on. So that's going to be my first inequality that I graph. Okay, for my second one, this says start at 3. This one has a slope of positive 2. So it says go up 2 and right 1, or go down 2 and back 1. Because it's less than or equal to, it's a solid line. I use my test point again of 0, 0, which is right here. It's on this side. Okay, and I'm going to determine if it is a solution. So plug in 0 for y, plug in 0 for x. Again, it's a solution if it makes it true. So 0 is less than, well, 2 times 0 is 0, and 0 plus 3 is 3. Is 0 less than or equal to 3? It is. So that says shade on the side that has 0. That would be on this side right here. Now, my solution to my systems of equations are where the two shadings overlap and they overlap right here. So this would be my solution, this region right here. So all my points would be in the shade, all my solution points would be in the shaded region or on the blue line that's in that shaded region. Let's look at the next one. So both of these are in standard form, so I'm going to need to change them. To change the first one, I just subtract 3x on both sides to get y by itself. So pretty painless there. Y is greater than negative 3x plus 5. So if I start graphing this one, I'm going to start it at 5. This has a slope of negative 3, so I go down 3, right 1. I can't go up 3. Because it's greater than and not greater than or equal to, it's going to be a dashed line. I'm going to use my test point of 0, 0. Okay, to see which side I should shade. So 0 is greater than negative 3 times 0 plus 5, which means 0 would be greater than 5. Is 0 greater than 5? It is not. So that says shade on the side that does not contain 0. So that would be shading on this side over here. I look at my next one. I would have to subtract x on both sides, since negative y is less than or is greater than or equal to negative x plus 2. Then I would have to divide everything by negative 1. Remember that when I divide by a negative, it's going to reverse the inequality sign. So instead of greater than or equal to, it's going to change it to less than or equal to. Negative x divided by negative 1 is positive x, and 2 divided by 1 is negative 2. So it changes to y is less than or equal to x minus 2. So it says start at 2, or negative 2. This has a slope of positive 1. So that means go up 1 and right 1, or down 1 and left 1. This will be a solid line. And it's a solid line because it is less than or equal to. I'm going to use my test point of 0, 0 here. So if I plug in 0, 0 into my point, it should, if it's not a solution, I'm going to shade below. If it is a solution, I'm going to shade up. 0 is less than or equal to negative 2 is what this says. That is not true. So I'm not going to shade up. I'm going to shade underneath. My solution here would be right here. Again, where the shaded regions overlap. So my solution would be where my two shaded regions overlap. So I get this next one. So we have y is greater than negative 2. So that says I have a horizontal line at negative 2. Y is greater than that. So if I use my test point of 0, 0, 0 is greater than negative 2. That is true. So I would shade everything that is above negative 2. Okay, for this next one, we have x minus 2y equals 4. I would subtract x on both sides. I would have negative 2y is less than or equal to negative x plus 4. Divide everything by negative 2. Don't forget that when I divide by negative, I need to reverse the inequality, so it's going to become greater than or equal to negative or positive, I guess. Positive 1/2, because that would be x divided by 2, x minus 2. So this says start at negative 2 and go up 1 and over 2. Up 1 and over 2. up 1 over 2, or down 1 and back 2. Okay, this would be a solid line, because again it's greater than or equal to. If I plug in 0, 0, which is right here, as my test point, I get 0 is greater than 1/2 times 0 minus 2. Well, 1/2 times 0 is 0. So that would just be 0 is greater than -2, and that is true. So I would shade everything that is above. Again, my solution is where the shaded parts overlap. So my solution would be in this region right over here. Okay, if we're looking at a real-world problem, we have the owner of Fred's Fish Market orders cod X and salmon Y. He wants to buy at least 50 pounds. So if I'm writing my equation for this one, it would be X plus Y is greater than or equal to, at least would be greater than, is greater than or equal to 50. Cod costs $4 and salmon costs 7. So 4x plus 7y. And he cannot spend any more than 300, so he's got to spend less than or equal to 300. Our variables here would be amount of cod, y would be amount salmon, and we can solve these using the graph. So I would have to subtract x on both sides here. So I would have y is greater than or equal to negative x plus 50. So if I start at 50, and down 10 and right 10 would be the same thing as 1. Down 10, right 10 would be the same thing as 1. Okay, so this would be solid again. Everything that is greater than, what do I have equals to there? Everything that is greater than or equal. So greater than or equal to here would be everything that's above. And I can look at the inequality when it's in slope-intercept form and just rely on the inequality to shade. If it's only when it's in slope-intercept form, though. Okay, so changing the next one, this would be 4x. So this would be 7y is less than or equal to negative 4x plus 300. Divide by 7. So y equals negative 4/7 x plus, should be about 43. When we divide, I don't have to be super exact here. So I'd start at 43. And this says go down 4. And write 7, which would be the same thing as going down 40. So it's 1, 2, 3, 4. Write 7. 1, 2, 3, 4, 5, 6, 7. So you put a point there. This would also be solid. Try to get my line as accurate as possible. Okay, this would be less than or equal. And so because it's less than or equal, I would want to shade everything below this line. Remember that our solution is where the two overlap. So my solution would be in this tiny little sliver right here. That would be the possible combinations that he could have. Again, before watching the next video, what I would like for you to consider is how we use a test point to determine which side to shade.